Hey guys, my name is Jason Ibarra, and today I'll be talking about my AP Stats project. So, my AP Stats project was named Where Do I Stand? So, in this project, I'm taking multiple data points such as height and, so I specifically put gender as well in there to have it as a factor to consider as well. So, just to go over like a basis, what I'm gonna be talking about in this video is I'll be talking about like the heights of people, like obviously where I stand in terms of percentile. We'll be talking about certain like other like the basics of stats pretty much, like have a 5 number summary. We have multiple things with that. We'll be also going about 2 different graphs. We'll be talking about dot plots and also box graphs. So yes, please enjoy this video, and like and subscribe. Alright, so here's my stats right here. I know you can't see them, but maybe you want to zoom in. Okay, just make sure not under, you know. So these are my stats. So pretty much what I did, to be honest, it was a convenience sample. You know, if they were in my class, I took them as a sample. Most of these are 17 to 18-year-olds. Something to consider when we do research on other stats. So I took height and I took gender. So also for height, I converted to inches instead of staying in feet and inches, simply because inches is better to deal with when it comes to numbers. There's not a lot of scrambling and having to convert to decimals and all that. It's just simply better when you do in inches. So yeah. So I ended up getting my data on a dot plot. So yeah, this is pretty interesting data. I mean, I'd say so. Look, like the fact that it's multimodal model. It has multiple peaks, which is interesting. I actually didn't expect this with a peak over here for the tall people, essentially. Like, I did take a couple tall people. I didn't expect the skew, like there to be this big of a skew, but yeah. So yeah, it's actually skewed to the right. So I know it's inverted on the camera. I'm sorry about that, but it is skewed to the right. So yeah. So the way skews work actually are, whatever side I guess it's skewed to, it's actually gonna be the opposite, which is interesting. It's an interesting concept in stats. So yeah, we have a skewed to the right multimodal dot plot right here. Yeah, it's pretty interesting. So back to our graph, right? Or actually dot plot, my bad. So this is our dot plot, multimodal, skewed to the right. We got that all covered, right? So we're actually gonna calculate mean, and I did it a pretty elementary way. Some might consider. So for mean, I would just get like a point here, cross it out, point here, cross it out, until I got to the middle. And the middle ended up being 65, which is also the highest percentage of people I got. So for 65, it would be our mean. And interesting, I'm also 65 inches, 5'5" for people who don't know the conversions from inches to feet. So yeah, so 5'5", I'm 5'5", and this will put me in the 50 percentile of the people of the stats I took today. So yeah, I'm in the 50th percentile. There you go. So I wanted to know personally how I felt in this graph. So to do that, I calculated behind the scenes a more specific mean, which I got 65.721, which was my mean. And I also calculated behind the scenes the standard deviation, which I got 3.756. So to specifically find how many standard deviations I was away from the mean, which I was actually pretty close, but I went like no specific numbers. We could use z-score. which is a pretty interesting concept of how many standard deviations you're away. So to find z-score, we will need x, our data point, and we will subtract what is that? Our mean, and we'll divide that by standard deviation. So I did the math, right here, and I ended up getting 0.19196, which is it's a -2, which means that's how far off I was from the actual mean. So in terms of standard deviations, I really wasn't close to this number from being far away. So I was pretty within the original standard deviation. So for my data plot, I also decided to add a box plot, which is another basic thing we learn in stats, and also a very informative thing we learn in stats. So for my minimum, we got 60. For my maximum, we got 73. For what is this right here? It's Q1. Sorry, I got 63. From a median, with a box plot, it does help find the median instead of a mean like here. So for median, I got 65. As we know, it's pretty similar as well. So and for right here, the Q3, we got 69. So as we look at it, it's pretty similar in terms of the shape. Also, fun thing to note. Fun thing, yeah, it's pretty fun. Like, it's an interesting stat that I remember learning throughout this year. So yeah, sorry about that, my phone died. But an interesting thing I learned in this stats class was that when you have stuff like this, and let's say we add a number because someone joins in the data, right? The mean will likely change. The range is gonna change, or the range might change depending on where the person we add is. A lot of stuff is gonna change, but one thing that won't change is median. So no matter if we add someone, we take someone out. That I thought that was an interesting fact. Like the fact that if we add someone, take someone out, the median will always stay the same, but mean and a bunch of other factors will change. I want to go a little bit more into depth when it came to my personal height. I'm male. So as I previously mentioned in my data points, I included gender. So our total of males in the study was about 23, I want to say. Yeah, 23. So I decided to factor in their own plot, So for this one right here, this graph specifically, we don't have too much of a heavy skew. Maybe just a slight skew right here because it leans more here, but it's also, not approximately normal. So yeah, so there's a slight skew. As you can tell, there's two peaks, so that makes it bimodal. Not like the other one was multimodal because, we had 3 peaks, but this is bimodal because we had 2. So I want to calculate the mean again in a more specific way. So behind the scenes, I got this mean. Let me check. I had it right here. Sorry. The mean I got for the males was 68.435. And I also calculated standard deviation behind the scenes, and I got a 2.858. So yeah, thank you. So I want to see where I personally stood in terms of how many standard deviations away from the average, which, reminder, I'm 5'5", so yes, 65 inches. I forgot to add inches again, sorry. But yes, so we use the same formula, x minus mu over standard deviation. So yes, so x is the data point, so me, 65 inches, minus the mean, which is 68.435, over the standard deviation, which is 2.858. And after this basic math, I got a negative, which means I'm below. I'm 1.202 standard deviations away. It was negative, so I'm below the average height. Thank you. So yes, I also made myself a box plot for here. So for the minimum, we got 64, and for maximum, we got 73, which gives us a range about 9, I believe. So for Q1, we got 65. Q3, we got 71. So we also got the median of, what is this, 69. So yeah, well, it's not exactly 69, but it's close enough to 69. So yeah. Hey y'all. On my data, I also just wanted to talk about the data itself. There could be many variables when it comes to data. One thing we had to consider, which it's gonna happen. It was a convenience sample. We were talking to people. There was people around. We have a response bias. So pretty much the response bias comes from they're around people, so there's a possibility like, oh, they don't want to fake their height, or they want to seem shorter or taller. So yeah, the pressure can get to people. So you don't understand that there's a response bias to it. And yeah, thank you for watching my video. I really appreciate it. It's one of my first math videos, so I'm a little nervous and stuff, but thank you. I also want to say, on this data, if I misspelled your name, I'm sorry. Alright, I don't know how to spell all your names.